Okay, hi everybody, and thanks for joining us today for our Deep Understanding and Problem Solving in Essential Maths webinar. Um, just a bit of housekeeping, first of all. You can download these slides. I'll make them available after the webinar. I'll send you a link to how you can get to them. So my name's Robert Yen. I'm the publisher at Nelson Cengage, and we recently published new editions of Nelson Maths for QCE Maths. So we publish in Essential Maths, General Maths, and Maths Methods. And today we're talking about the Essential Maths books with Sue Thomson and Judy Binns, the two authors. And I've also left my email address and our website so that you can find out more by writing to me or going to the website. All right, let's get started. So as I said, we also publish in General Maths and Maths Methods, and we're actually offering 2 more webinars in the next 2 weeks on the Thursdays. So you can, if you're interested in Maths Methods, we're offering a webinar on Maths Methods exam analysis and tips. And then the following Thursday, the 21st of August, General Maths exam analysis and tips. And that's with our authors, Anna Weatherald and Sam Hodgson. And we also publish for years 7 to 10. So we do have a year 7 to 12 series. So we publish Nelson Maths 7, 8, 9, 10, and we offer 2 levels of textbook for years 9 and 10, and then 3 levels of textbook for years 11 and 12. And last year we did some webinars, and in fact, Sue and Judy did one on what's new with QCE Essential Maths. And so if you want to find out more about what the changes are to the syllabuses, you can go to our Nelson Secondary YouTube channel, and you'll find out also about General Maths and Maths Methods. And before I hand over to Sue and Judy, I just wanted to let you know that they have been writing together for quite a while now, and they're specialists in writing for the Essential Maths level. And they haven't only done it in Queensland, but they've also done it in New South Wales, Western Australia, and Victoria. Some of you more experienced teachers might know that that Sue Thomson wrote the Access to Pre-Vocational Maths with her husband Ian Foster back in the day, before the new QCE courses came about. But she's quite an experienced maths teacher and leader, and she's also been involved in curriculum and exam writing and marking. And Judy Binns also has been teaching and leading in schools for quite a long time. I think they've both been teaching for at least 30 years. And Judy has an interest in motivating students with learning difficulties, as well as being a co-author on the Nelson Maths 7 to 8 books. So yeah, as I said, they've written for New South Wales with the Maths Standard 1 course, Victoria for the Foundation Maths course, and WA for the Maths Essentials course. So yeah, quite a lot of experience writing for Essential Maths. Okay, so I'm going to hand over to Judy now, and she's going to talk to you about the Essential Maths student.
I just wanted to talk before we start talking about how we actually do things. It's important to understand the sort of students that we tend to have in these courses. It's designed for students who are going to go on to training or work from school rather than further tertiary study. These students are often not necessarily happy to be back at school, not necessarily very interested in school. Excuse me, they're often anxious about maths or don't think they can do it. They often think that they're not good at it. They've failed in junior school and they just don't like maths. What use is it? What good is it? And so I guess it's up to us to change some of that. They think that maths is irrelevant. You will get some students whose focus is on other subjects, but they've been told, oh, it's a good thing to do maths. And so they have taken the lowest course possible. So it's quite a range. The other thing to remember is that these students are often working part-time. they're often not highly motivated to do school anyway. And so you're not going to get them doing huge amounts of work at home or outside of lesson time quite often. Obviously, these are generalisations, and you'll have students across the whole spectrum. And so we now want to look at how we can develop deeper understanding with these students. How do we build their confidence? And how do we turn around the attitude that they can't do maths and get them to see that they can understand what's going on, particularly when it's put into a context that they are familiar with. And so we just want to consider some strategies for how you might go about teaching this type of student. And I'll trying to give you some examples of what you can do in the classroom. Some of you will know these, and please be assured I'm not trying to tell you how to teach, but I do think it's useful when teachers share things that have worked for them. And so we try to teach maths at this level by using relevant, practical, real-life examples. Now, it's probably fair to say that no one example will suit every child, and there's no one thing you can do that every student will be interested in. But if you bring to that you're teaching a variety of real-life examples, then different students will engage more at different times. It's important often to use your own experience to set up a problem, or, what do I do in this situation, or look at what I did. And it's also useful to use local examples of things that you can refer to. If you're finding the area of the sports ground, make it a local sports ground, okay? That sort of thing. It's good to provide opportunities to be successful for the students, because if they are successful, that builds their confidence. You might choose to do 10 questions at the start of every lesson, but make them questions that they stand a good chance of getting 10 out of 10. Don't make them so hard that they'll just be put off. And so it's a good chance there to provide opportunities for success. Also, often doing assessment tasks in class rather than expecting them to do work at home can help them to be successful. You need to adapt to your students' interests and experiences. It depends where you live, it depends what they do with their time, and so on. And so only you, the teacher, really can work out what sorts of things are most relevant to them. But use your own environment to bring things to them. It's a good idea, and I really think I'm probably telling you something you already know, that you keep your explanations simple and decluttered, with a focus on the terminology and literacy. Some of these students will be quite good with literacy, but others, they will struggle in literacy as well. And so it's important that they know what words mean, what they're expected to do. And so to do that, and you probably do this every time you write an example on the board. You don't write 3 paragraphs of explanation. You write it in a simple and straightforward way. And that's the sort of thing that helps these students to understand what is going on. It's a good idea now. We can use technology, in particular in this course. Spreadsheets and online calculators are a huge bonus for us. Teaching a student how to use a spreadsheet has many benefits, not just in this course, and it also helps students to feel that they're not stuck on the same old maths they used to fail at, but that someone else can take over all that and they can actually look at the problems and so on that they've been asked to consider. It's important to not just have these students sitting down all the time. If you're doing measurement, get them up and measuring, whatever it happens to be, in the classroom, outside, even trigonometry, measuring angles of elevation, whatever. And so helping them to see that maths is not just, here's an example and now you do 20 questions. It actually has things you can do in it. And so the more you can get your students doing stuff, I find that they tend to enjoy actually doing stuff. And lastly, use the power of the internet. I mean, it sounds funny, really. Use the power, Luke, is a bit how it sounds like. But in fact, the internet gives a lot of opportunities. You can find so much information there. Things like car insurance. When you did car insurance in year 11, a lot of that can be done on the net. In terms of things like floor plans, If you're doing stuff on floor plans, let the students find their own and answer some questions about it, or make up questions about it for other students to answer. And so I think the internet is only, your use of the internet is only limited by yours and possibly our imaginations in what we've suggested. But it's a very useful teaching tool.
Here we have a list of the chapters that we put in the Year 11 and Year 12 book. Going on from what Judy was talking about, you can see we've structured our chapters around things that interest students. Of course, not every student will be interested in every one of them, but we're hoping that at least there'll be something that attracts somebody each time. They're things that students have to do every day. And we start with applications and a theme rather than starting with all the maths. Now, for example, we could look at the topic investing money, something that's quite important. And our first chapter, the chapter on it, here we go, here's the chapter on it. You see, this is what the first page of the chapter looks like. We start with a chapter problem, what this chapter's all about. We give the kids opportunity to be successful solving problems that are real and relevant to them. This question about Ryan and Melanie actually was one that came from my partner's family. They're two of his grandchildren who had money to invest. So there's an absolutely practical question that comes out of real life. For our first page of the chapter, we tell you what's in the chapter, but most importantly, what are we going to do with this chapter? Why do we want to know what's in this chapter? We've all heard students for years say, but what use is this? Why do I need to do it? So we're looking at really important things. One of my favourites is to help them learn to avoid financial scams, something that's close to my heart. Here's another example, the first page of the scale drawing chapter. Now, this we hope with the interest that everybody seems to have in the block on TV and house and garden, where renovations are very popular activities. Here we teach the maths of scale drawing through what they are probably interested in, and they can see the relevance of it. Also at the front of each chapter, we do the teacher talk. What's in the syllabus? So the initial bit is what's in it for kids. Now it's what's in there for teacher. And we have a list of support materials. Busy teachers don't have a lot of time to come up with all of these things. They're there for you. They're there to use. Terminology. Now, this is near and dear to my heart. I've learned from having a language disabled child the importance of understanding key words. And just one example from my life that brought it home to me. In the beginning time when I was first trying to load a computer program, I was following the instructions. Well, or thought I was following the instructions, and it said type period. So I did, P-E-R-I-O-D. And then it said to me, no, type period. So I thought, oh, did I spell it wrong? Try again. No, I didn't know that a period was a full stop. There's one simple word I didn't know that meant I couldn't do anything. I had to get a Year 11 kid to come and help me. That's what our students are for. Some of them know a lot more than us in some areas.
When we get into our chapter, we try to present things with clear and simple language. And in a way, I think what we're doing is reflecting what you would do in the classroom. You don't give your students a board and a half of work to copy down, or if you're on a data projector, a page and a half of notes. You actually try and break it down. That's what we call chunked content, that you might give an important formula, and you put that up and you put stars around it or whatever you do to highlight something. That when you're doing the exercise, examples, you don't, again, put a whole lot of explanation. You try and put it in a straightforward and easy to understand and follow way. And so I feel that we're not doing anything you don't do already, probably, in your classes. So here, for example, is the simple interest formula. Another thing we try to do, linked to what Sue was saying about language, is that we have a glossary. And so whenever a term comes up for the first time in our book, and it's in the glossary, we highlight it in the bold blue. So in this example, we've highlighted interest rate and period, not the one Sue was talking about. And so students all then know that they can go to the glossary at the back and check out what it means if they've forgotten. You'll also see on the left-hand side of this section presented here near the simple interest formula are an example of how we reference those resources that are on that beginning of the chapter. And so in relation to simple interest, we have a video, we have some worksheets, and we have a puzzle. And then you don't have to go searching for, oh, what have we got on this? What can I find on this? It's there for you. You can look at them and you can choose what might interest you and your students. We then go on to look at how, in other cases, it might be useful to use diagrams, known as infographics, and hints. We try to put hints in the book for both you and the students. And so when we have an example or we're trying to tell them about something, then we put in a hint. It's there in the orange box. And so it's just a reminder that if you want to go in this question from 4.5% to be able to use it in the formula, you have to change it to a decimal. And so it's just a small reminder of something they should know and be able to do, but sometimes forget. Also in your syllabus, you will probably know that there is a list of cognitive verbs from the syllabus, and we have highlighted those at different times and whenever they're used during our examples and so on. And the importance of this is that students need to know what you're asking for. If you say calculate, if you say evaluate, I have lost track of the number of times students have asked me, what does evaluate mean? Because they're just not sure what to do. And so it's important that we use a variety of these cognitive verbs and that we make sure the students know what they each mean.
Here's an example of a work set that we would start with. You'll notice that in the first few questions, they're linked to examples. So if a student needs to, they can link back to the example to get a hint as to how to go about doing them. And we lead them through ways of learning the topic. Then we come to problems. And you can see that there's a blue PS down on the right-hand side, indicating that what we've got there is problem solving. Now, a lot of people say to me, where do you get all your problem-solving problems from? Well, if you keep your eyes open, your life is full of them. Question 12 about Kelly, she was actually our neighbour. And the story of her buying a new house before she sold the old one and having to have bridging finance is actually totally true. Something that students need to be aware of, that there are these traps that you can fall into. Similarly, in question 13, this is another one that actually happened to me, but it wasn't Darren, it was Steve. And I knew Steve years ago, and one night he rang me up and wanted me to take out an investment with him, and it screamed scam all over it. So there's a question. Give it to your students. The students will love it that somebody tried to scam their maths teacher.
Okay.
And so,
yep.
And so we have here, for example, we've said that we try to make the examples practical and so on, but we've also tried to include references to Queensland in the book. And so question 6 on the left-hand side there is set in Queensland about going to visit Longreach, and hopefully that will just this will make some of these examples a little more immediate. And you should do the same thing in your classroom. So we're trying to support you and give suggestions, But if you've got somewhere, or you could say, oh, well, let's do something on a family visiting our town and work out distances and the other scales and so on. It's the two on the right-hand side are the scale diagrams. And again, PS all around, but you'll also see in there that there's a C. You'll know if you've already teaching the course that there are complex dot points in the syllabus. And so anytime that we're doing something that has been labelled complex in the syllabus, we've added a complex symbol, just so you know that we're dealing with that aspect of the syllabus, and also that students may struggle. Sometimes it's a good idea to challenge them and say, oh, I don't know that you'll be able to do 10D. It might be a bit hard for you. And often that is the motivator for them to show you that it's not too hard for them, depending on the students, I guess. And you know your students better than we do.
Investigations. They're a key component to this course and something that I would encourage every student to take on. This is an example where we can use online calculators. I recommend the Money Smart calculator. It's a federal government site. We do very well teaching students that compounding interest is usually the one that pays the most, but it's not always true. So being able to get on and use an online calculator or a spreadsheet that probably even exists in your school already can help our students to get an answer that's right and then be in a position to make deductions from their answers. Often when it's a calculator question, they get carried away in their calculations and forget what they're wanting to do in the long run anyway. The use of the technology in the investigations makes things quick and efficient. Another investigation, as I said before, I'm very much into avoiding scams and having people know about them. Here's an investigation that takes them through the scam website, the Scam Watch website, to look at the ways that people are being tricked out of their money and hopefully have them not fall for it themselves and maybe help others to not be scammed. How accurate is your GPS? I don't know about you, but we've got a statement in our family talking about having a GPS experience where the GPS takes you the long way, or it says things like, now catch a ferry, or it says that it's going to take you 2 minutes and it takes you a lot longer. That was the inspiration for this practical activity. Well, let's have a look. Let's learn how to use GPS because it's a useful skill and see how accurate it is. Does it really give you the right time around your area? So it's an activity I would recommend you ask your students to do. They'll enjoy it and they might learn something. This example 12 is about an investigation into different compounding periods and the effect that it has on the value of your investment. We use technology for it. We supply websites, we supply spreadsheets, and I would recommend that you try and use them. The kids actually like doing this kind of stuff. Is compound interest always better than simple interest? We do very well having students learn that compound interest is good, but it's not always the better of the two options. And using technology is the way to investigate it and come up with some correct reasoning. Language. At the end of each chapter, we have a keyword activity to reinforce the language that we've learned in the chapter and what it means. We have different sorts. The first one here is a word match. The second one is a close activity. A lot of our students are quite good at language and enjoy this kind of thing. Not all of them, of course, but some of them are very good at English and language, and it makes them feel successful using these as well. we have quite a range of different styles of language activities.
So we come now to problem solving. As those of you who have taught the course already will know, the syllabus places great emphasis on problem solving, and it provides this diagram for the process of problem solving. Now, we've taken that syllabus diagram and made our own little fancy process with a circle and 4 different coloured quadrants. And so, but it relates to that, and when we get to the end of each chapter and give a solution, then we follow this process. And so stage 1 is formulate, which we've called what is the problem, what do we know? The second stage is solve, and that's what you have to do. So that's doing the maths, working out whatever you need to do to find the answer. Stage 3 is called evaluate in the syllabus. We've called it check the solution. If you've worked out that your employer is going to pay you $3 million every week, you've probably made an error somewhere in your calculations. And so checking the solution can help you with that. And then finally, present the solution, or as stage 4 is called in the syllabus, communicate. Tell someone else or whoever might be reading it what the answer to the problem is. It may be as simple as a single sentence, or it may be something more complicated. And to just show you an example of what we do with our chapter problems, this was the problem we looked at earlier in this webinar. This is the one from the start of the Investing Money chapter about Ryan and Melanie investing $25,000. And so we take them through the process. At some point in the chapter, there is a box that says, you've learnt what you need to know now to solve the problem, go ahead and do it. So we're hoping that students will have had an attempt at solving the chapter problem and then come to this to see and compare how they did it with what we've presented. And so what is the problem and what do we know? Stage 1, there are 2 things here. We have to work out whether Ryan or Melanie have earned the more interest. And so that's the basic problem, but we're given a whole lot of information for each of them, how much money they have, how long they're investing, and the interest rate. So that just brings those numbers out of the sentences and into a clear way, in this case in a table. And so then in stage 2, we actually do the calculation. We work out Ryan's interest using the compound interest formula, and we work out Melanie's interest using the simple interest formula. An important note there is and it was one of the good things about this problem, is that it reminds students that the compound interest formula gives us how much we have at the end, whereas the simple interest formula gives us the interest. So when we're doing compound interest, we have to subtract the original money that, in this case, Ryan invested to work out the interest. Just a simple reminder of something that can often trip students up. And so we can work out the difference and then we can consider that. So in the red quadrant, check, both are about the same. So that says they're probably correct. There's not a huge difference. If we got one as 3,000 something and the other one as 30,000 and something, that would suggest that there's a problem there. We've also included a few comments on the problem itself that helps students, we hope, to think about these in a common sense way. And then lastly, we present the solution that Melanie's investment will pay $28.40 more than Ryan's investment. So a simple statement to answer the question. And so this can be applied to any of those problem-solving questions that they have at different times. It can also be applied to what you might set for an assessment or an investigation. So it's a process that hopefully, because we've used it through year 11, if you're using our books and have used it, they will be pretty familiar with by the time they get to year 12. But it just gives them a way into problems, we hope.
Yeah.
Now,
I've just noticed that with these chapter problems and all your investigations, as well as the using technology, it's all part of a bigger package. And it's showing us that we're teaching more than just drill and practice. We're teaching them more than just the simple interest formula, how to apply it, and the compound interest formula and how to apply it. We're actually using it in context to solve a real life problem. And hopefully through this, it'll engage students and strengthen their deeper understanding.
Mm-hmm.
Yeah, okay.
Absolutely agree with Robert. It is essential that we use maths. We don't learn maths so that we can copy down solutions. We learn it so we can solve problems. It's a life skill.
Mm.
Yeah, okay.
Yeah,
and then we
that's
come to the
true.
chapter, the test yourself.
Now, at the end of every chapter, we have a chapter review, and we call it Test Yourself because it's a way of students discovering what they've learnt, what they remember, what they don't remember, what they need to perhaps do more work on. And so you'll see that each question is referenced back to an exercise. If they're totally stuck, they can go back to that exercise and see how they did it. It can also be used as revision at some point down the track if you have set an assessment task that uses the skills from that chapter, then you can use this as a revision. They can do it several times, it doesn't really matter, but it is a way of both self-assessing performance and then helping them perhaps to improve performance if needed in the future. After every 3-4 chapters, we also have practice sets. And I guess this is a slow introduction to the type of things they might find in an exam where everything's mixed in together. So in this case, practice set 3 in our Year 12 book, that covers chapters 10 to 12. And so the questions are mixed together of all different things. They're not in the order they were done in the chapter. And this practice set would not be done immediately after you'd just done a topic. It would be further down the track. Again, it can help students prepare for exams, and we were careful to look at what sorts of things have so far been in your external exams and to make sure we covered those sorts of questions in doing these things. But it just is helping to get them. A lot of these students can do it when you're doing it. They might even still be able to do it at the end of a topic after 5 or 10 days, but coming back to things later can be an issue. And so that's why we have these practice sets.
Okay, now we're going to look at the science of learning, which is something that is featured in the new syllabus. So it's on page 11, and it's strategies for retaining and recalling information for assessment, or as I like to call it, just how to improve deeper understanding and retention, and improving using your long-term memory. So this comes from research into cognitive science, which you might have heard also called cognitive load theory, or how the brain remembers things. So it's based on research, and the researchers' names are listed at the bottom of the page there, and that just focuses on 3 strategies, 3 memory and learning techniques. It's called the spacing effect, the retrieval effect, and the interleaving effect. And we were quite excited when we saw this featured in the syllabus because we already write our maths books this way, so it fits in really well with the model that's being proposed by the syllabus. So the first one is the spacing effect, and that's when you leave gaps between each learning session or lesson, I guess, or when you're studying, it's important to leave gaps between your study and not to study the same thing for a long period of time. Otherwise, it may be too much for your brain to handle, and you'll lose some of that. So having a rest and then returning to concepts improves your memory. It strengthens long-term memory, and having a break means the brain has time to absorb the information. So to me, spacing is like when you're watching. I know people like to binge watch a whole series of a TV series on Netflix or whatever, but it's sometimes better to do it over time so that you do retain your enjoyment or understanding of the story. Sometimes if you watch it all at once, that's great at the time, but then you forget it all. So that's spacing. And then the second one is retrieval. Now, a lot of all these strategies are pretty much common sense when I explain it to you. Retrieval means having regular practice sessions, short drills and quizzes, and struggling to remember things without referring to notes. And the more the struggle, the more the learning will stick. So just after every time you learn something new, allocating time to practice that thing before moving on to the next thing. So it's called retrieval. And then finally, we've got something called interleaving. Now, the traditional method would be of learning and remembering things would be blocking, where you do one topic, get to the end of the topic, then do the next topic, and so on. But interleaving suggests that you multitask basically, but in an effective way. You alternate the learning of topics so that students cover 2 or 3 different areas over the same period. So you mix it up a bit. You might start with an algebra topic, and then instead of doing another algebra topic, you might do a statistics topic or a measurement topic or a probability topic or a financial maths topic, so that there's a bit of variety. I mean, variety is the spice of life, and you are more likely to enjoy and remember things if you mix it up. So those are the 3 different types of learning and retention strategies. And how do we implement it in Nelson Maths? Well, you'll notice that we do have 16 short chapters in each book. They're short so that you don't spend too long laboring over a chapter. And it also allows you to have a bit of a break from it before you learn more from the same topic. We've also got interleaving in that we're alternating between different types of skills and topic areas. Each chapter ends with a test yourself review exercise. So that's the retrieval coming into account. And then each block of 3 to 5 chapters ends with a practice set of exam style questions. And that's interleaving again, because you've got mixed review, mixed questions, as well as retrieval. And at the front of each of our books, we do have a syllabus reference grid. So here's an example of us mixing things up. So you'll notice that if we're not going to teach all the measurement topics all together in one block, because that would be boring, wouldn't it? So we mix it up. It's chapters 1, 3, 4, and 7. So we try to spread it out over the year. And that's the other thing. If you spread things out over a year and you go back to it, that also strengthens memory. But if you taught measurement in term 1 and then didn't teach measurement again, then your students are more likely to forget it. Okay, and then we've also got this list of mathematical verbs, which I think Sue's going to talk about.
I was going to have something to say about that. There's lots of verbs that we have from maths, and the ones that are listed as cognitive verbs in the syllabus, we've highlighted in green, but they're not the only ones. There are lots of others. So we've got a list of them at the beginning of the book of what all of the different verbs mean, and so to help students know what they've got to do.
Mm-hmm.
And at the end of the book, we've got a glossary. The first time a new word is used in the book, it's highlighted in blue, and there's a page reference to it as well. For example, you can see 2D shapes. It was used on page 51 for the first time, and students can use this to check that they actually do understand what the term means.
And so just to bring together what we hope are some of the ideas we've presented today, that this course has a focus on practical applications of maths and problem solving. It's about using it in real life. And the more you can do that, the more successful you will be with your students in teaching them this course. That we have implemented a thematic approach to learning maths, so around investing money or around floor plans and renovation or around whatever, all those different things. And you might come up with some of your own that take what our ideas and apply them in your own local area or school situation. Problem solving is a major component of the syllabus, and we have not only had chapter problems, but we've also highlighted problem-solving questions within the text. And of course, they're often part of the investigations. And complex questions are also colour-coded, just relating them back to the syllabus for your information. We have a chapter problem at the start of every chapter, and you might even like to make up some of your own, again, that are more relevant to you, but it gives students an idea of how the work in each chapter is going to be useful. And at the end, we have the keyword activity, the solution to the chapter problem, and the test yourself exercises. So we hope that the whole bundle will support you in your teaching, will help you to present this course in an interesting way for both you and your students, and that it will be of use to you at different times during your teaching, and for you to be able to ensure that you have covered the syllabus as you should do.
Okay, I want to briefly mention Nelson MindTap, which is our online digital platform. So this is where all those little icons there that show you videos and worksheets and puzzles, where you can find this all these extra resources to help you. Now, the important thing is if you do buy our, if you do purchase our textbook, these resources are only available to schools that adopt Nelson Maths, meaning you buy all your students have access to it. So you need to, it's not available if you just buy one textbook, but it does. But if you buy a class set or you book list this text, you get access to the ebook. You get access to chapter PDFs. So in case your internet access isn't reliable, you also get access to videos by flipped classroom teachers, and also 100 plus worksheets, puzzle sheets, skill sheets, and spreadsheets. And then for teachers, we also get access to topic tests, teaching plans, and work solutions to every exercise in the book, which you can switch on for students as well. So you get access to, so it's the full package. But the important thing is that you do need to adopt the series for your class and not just buy a teacher copy. So if you want to know more, well, first of all, this is the pricing. So it's $79.95 for a printed book with the MindTap resources. Or if you don't want a printed book, it's $29.95. So you get an ebook with the MindTap resources. And this Year 12 book's being published next month. Okay, so all the Year 11 books have been published now. But if you are interested in previewing this book, you can contact one of our sales staff and get access to the page proofs. Okay, so you might know these people because they service your school. So it's either Amanda Cunnington or David Truman with their email addresses and their phone numbers there. And then finally, if you want to know more and you want to write to me about it, there's my email address there, robert.yen@cengage.com, along with our website. And if you want to download this PowerPoint, you can go to tinyurl.com/Nelson Essential Maths 2025. Now, Sue and Judy, do you have anything to add? Because we've come to the end, the last slide of our webinar. So
I'd just like to say thank you for listening to us, and we wish you all the best in taking care of these students who are often those that most maths teachers don't care about. They're often disregarded, but they have the greatest need. And for them, I would really like to see you put in the biggest effort. So thank you and good luck.
I can't really add much to that. Again, thank you for listening, and we hope that this provides you with lots of ideas and help for you when you're teaching these students, who can often give the greatest reward when you see the electric light go on after years of not being able to do something. So thank you for taking the interest, and I guess good luck too.